Building an off-road truck in 2021 couldn't be any easier. There are more available aftermarket parts out there for vehicles than any other time before. Most things out there are ready to go. They're bolt-on, they're already pre-assembled, they're ready to install on the vehicle. But what happens when a modification that you want to make to your rig is not readily available on the market? This is where something called fabrication comes into play. So if you've ever wanted to build something from scratch on your own vehicle, you might want to pay attention to this episode because today we're talking about the basics of off-road fabrication. What is up, you guys? It's your pal Desert Chief, only on Driving Lines Chasing Dust, coming at you guys with another great episode today. I'm out here in Riverside, California, about to enter my friend's shop here, Chris Begley at Luxury Prerunners. He's been building all kinds of vehicles when it comes to trucks, 4x4s, SUVs, lots of custom work and fabrication coming out of this shop. So I figured he would be the best person to talk to today and teach me a few things about the basics when it comes to off-road fabrication. Now, admittedly, I am no fabricator. I know how to bolt things on, I know how to work on engines, I can do all kinds of stuff with tools, but I am no good with a grinder, and I'm even worse off with a welder. So I've always paid people who know how to do this stuff better than me to get the job done. But today I wanted to learn a little bit about some of the very basic things you need to know to fabricate your own parts on your off-road vehicle. Whether it's a light bar mount, or some roof rack accessories, or maybe even a few things on your bumper that you want to attach to it, just some of the smaller non-structural items. We're gonna go over some of the basics that you need to know if you want to start building these custom parts for your own vehicle in your own garage. And as somebody who is a complete novice at this kind of stuff, I can't wait to get in there and talk to Chris and see what he has to say and what he can teach me about the basics of off-road fabrication. All right, so we're just pulling up here into Chris's shop, and I can already spot a rig that I know very well. If you guys have been to any of the Nitto Auto Enthusiast Days or some of the Sand Sports shows, off-road expos, this is the one and only lobster wagon. I love this truck. Park right next to a really nice Can-Am over here too. I think Chris just finished this one up, so I'm sure he's gonna want to talk about it a little bit. Got those trail grappler side-by-side tires. It's pretty cool to see this mini little K-Spec style Ultra 4 inspired tire on a side-by-side. Got a nice Land Cruiser next door to it too. But this is definitely one of my all-time favorite rigs. The lobster wagon with the ridge grappler tread pattern graphics, I love it. Powered by a Cummins 12 valve, NV 4500 manual transmission. It's just so iconic. You see this thing and you know exactly what it is. You know you're cool when your forklift has a Nitto sticker on it. Looks like they're working on an I-beam Ranger here too. Let's see if we can't find Chris here. So this is a shop, Welding Sparks. Let's see. We got Chris right over here. What's going on, brother?
Hey, how you doing, man?
Long time no see.
Yep, nice seeing you, man.
How you been?
Good, good.
Dude, I love the shop.
Thanks.
It's awesome. You got some pretty cool projects here, and I can't wait to talk to you about some of the basics when it comes to off-road fabrication like we spoke about over the phone.
Yeah, great.
Yeah, so you guys have everything you guys need here to build pretty much anything out of metal.
Yeah.
Looks like you have all the tools. You guys got all the heavy equipment and stuff too.
Yep. Everything from shears, press brakes, plasma cutters, and
Cool.
CNCs. And
Super rad. Can you give us a quick tour of the place?
yeah, sure.
Awesome.
Oh, we got top saw and cold saw kind of lined up here.
Yep.
Various metal on top. And let's see, we got relay down here. So this is our TIG welding section area right here.
Yep.
We do the TIG welding. And then we got like sheet metal stuff over here. The press brake.
Yep.
Finger brake there for sheet metal. And then we got sheet metal shear there.
Mm-hmm.
Sandblaster, air compressor.
That's a big air compressor.
Yeah.
Big twin piston.
Yeah, sometimes to run the CNC plasmas,
Yeah.
you know, you got to have a lot of airflow.
Yeah.
With a cooler on top.
Oh, yeah, yeah.
That's an air dryer.
Yep.
That's what that does, so it dries the air. And then we got a two-post lift here for doing various projects. So
Yep.
we got a two-chassis truck right here. That
Oh, yeah, I can see that. It's a
kinda like a
huge
back
control
burner
arm. Look at
project.
this guy. Super
We've been
cool.
working on this for a while. This is kind of like when we're slow in the shop, we work on that.
Which is never.
Which is never. Yeah.
It's one of those 10-year builds. I know all about those.
Yeah, pretty much. So.
Yeah.
But yeah,
and then you got the table over there, right?
CNC plasma over there.
Yeah.
So we're actually cutting a couple parts out right now.
I'm really excited to talk to you about that because while it's not part of like off-road fabrication basics, it's something that has in the last few decades like revolutionized the way parts are built. And I think that a lot of people are now seeing the value in having one of these in their own home, even on a smaller scale, to be able to cut parts out and make things at home without having to do all the manual cutting and all that from just a sheet of metal. So I can't wait to talk to you about that later on, but we got a lot to cover. So this is awesome that you guys have everything here. And one thing that I notice when I walk around the shop is like most fabrication shops, they have machinery in them that are probably like old. Some of them are older than people who are working here.
Yeah.
But they're still cranking stuff out all day long with it.
Yeah, exactly.
And it's pretty amazing to see like the engineering that goes into just the tooling when it comes to this stuff. It's lasted this long and it's still making people money, So it's pretty cool to see that.
Yeah, a lot of the fabrication is derived from the war effort from World War II.
Right. So that's really where people are building stuff.
And stuff is still in place now.
Yeah.
As far as chromoly and TIG welding and tube fitment and
absolutely
stuff like that. So
all the technical terms we're going to go over in a little bit. Tubing and stuff like that.
Yeah. Sounds good.
I'm just so you know, I don't know how much you know. I'm a complete beginner when it comes to off-road fabrication in general. So I can bolt anything on. I can put a motor together. I can drop a motor into a vehicle. The only thing I really can't do is rebuild an automatic transmission, but who can? Okay. I mean, it's pretty hard. But when it comes to just building something from raw material, I'm just lousy at it, and I really could use some pointers on like what are some of the places to start off with. If somebody who wants to just do something as simple as build a couple of tabs for their bumper to put a light on it, or let's say they want to put something on their roof rack that doesn't have a provision for it already. Things that you can do at home. Those are some of the things that I want our viewers to learn, like some of the basics that you just need to know to get yourself started in this world of fabrication if you've never done it before.
So, there's definitely some basic tips I can give you.
Awesome.
So we've been doing this for 25 years. So
you guys
we
have
started
been doing it for a while.
out old school way of taking a cardboard template and figuring out what the tab or bracket needs to look like, and then transferring that into metal and either cut it out by hand with a saw or bandsaw or handheld plasma cutter.
And then you're grinding away to smooth it all out and shape it, put it up there, make sure it's right, take it off. It's a lot of work to do all that stuff. But that's how a lot of people get started with this, is they just start tinkering with little things and create little projects themselves.
And some of the other basic tools for that kind of stuff is a disc sander, a belt grinder, and then a bench grinder right here. So, and all these tools are, come into play for different applications.
What are some of the basic pillars when it comes to fabricating for any kind of vehicle, but mostly an off-road vehicle?
Well, having a plan set forth at first and kind of figuring out what you're going to build. Because you can't just, say, I want to start building something. So let's say, for example, you get a light bar. Okay, well, you got to position the light bar in a various place and how far away, and there's form and function. So we go for aesthetics, what looks good, but also what's going to work in an applied field. So,
walking that fine line between function and form. That makes sense.
Because you don't want to put a light bar, let's say it's going to work really well, but it's 4 feet up in the air above the cab. That's just stupid. It's going to hit trees and stuff. But, so we try to put it in a good spot. So put that light bar where you want it, and then figure out what brackets and tabs are going to apply for that application.
Makes sense. Makes total sense. So having a plan, first of all, and using that plan to kind of shape your design, I would and whether it's on paper or you're doing it on CAD software, if you're that savvy, which I'm not, but if you're just drawing things out like I usually do on some paper.
It's very good to draw it out and try to get a rendering. And even of the full build, depending on what you're doing, because some people are going to put arms on their truck, other people are going to buy a whole, they're going to build a whole 2 chassis truck eventually.
Of course, and there's a lot of different components that go into that, and you could have a CAD file that's just huge, full of all these parts and stuff, or you could have a book full of pages that you've drawn to make this happen. I assume that's how they did in the old days. That's the only way you could do it without a computer.
So I got a degree in graphic design, and that's helped me apply certain concepts and graphics to certain applications and trucks. And
that's awesome. So you can actually make them look good and they function well, because you know how the structural integrity and the engineering works in there. Very cool. Very cool. So having a plan for sure. And then I'm assuming the next step would be figuring out what materials you need to use to build it out of. Is that something that needs to be thought of?
And what the application is going to be. Are you rock crawling? Are you going fast through the desert? Is it just a weekend truck? Or is it just a show truck? So now if you're racing it, you want to use chromoly and thinner material to save weight. you know. So
let's talk about for the instance of this argument, we'll talk about like actual like metal tubing. So first of all, there's a big difference. We talked about this on the phone. They're not pipes.
Right.
They're tubes. Yeah. So there's a difference there.
Yeah. Plumbers use pipes.
Plumbers use pipes. Fabricators use tubes. Yeah. And tubing, people who don't really know about off-road fabrication, they look at a piece of tube and they couldn't tell you the difference from one to the other. Right. And there are differences in the material as well as the thickness, as well as like, their breaking strength or whatever you may call that, but tensile strength. Yeah. So I know a little bit about that. At the lower end of the spectrum when it comes to like, I guess weaker metal would be like mild steel or DOM which after that.
1010.
Yeah. 10, and then you go to DOM from there, which is drawn over mandrel.
Yeah.
And then from there you have chromoly, which I'm sure there's varying degrees. 4340. I've heard some of these numbers thrown around.
4130 is the most popular that we use in the off-road.
It's very strong and it's light and it can be thin. So I guess like a pretty typical size would be like an 1 3/4 or 2 inch tubing with like a 120 wall. Yeah.
Exactly.
So that keeps the overall, weight down when it comes to the parts. That's important when you're building an entire chassis out of tube because that's a lot of weight that you can really easily cut down on if you're using something like chromoly.
Yeah.
And I'm sure that the negative factor of chromoly is that it's expensive.
Yeah, it's expensive and it's a little bit harder to work with and bend because there's spring back on the bend.
Right.
So
you got to over bend sometimes and let it come back. Yeah, that makes sense.
So mild steel doesn't spring back as much, so it's a little bit easier to fabricate. So
maybe you can dispel. This is a myth that I've heard that DOM will bend easier, but chromoly at its very very weakest will actually just shear. Is that correct?
It is to a certain point, but it normally shears near the weld.
Yeah.
So that's why we typically try to TIG weld the chromoly so you get the precise heat.
Yeah.
When you MIG weld the chromoly, sometimes it can overheat the metal.
Sure.
Which will cause it to shear not right at the weld, but it's going to be like right above the weld.
Right beyond it.
1/8 inch or so. Right there.
Interesting.
So that's why we TIG weld because we can get precise heat.
Yeah.
At the perfect temperature.
So that brings us to welding. So this is a very, very basic, conversation of like, let's say you have two pieces of tubing that you want stuck together. Okay. So first of all, you have to shape those two pieces to fit together, right?
Yeah.
Let's say you have two pieces of metal, you want them to go together. We can use an example if you have one around here just to show like a, two pieces. We can go out to that Ranger over there. We can look at that.
Yeah. Ways to fit, tubes together. You can miter them.
Yep.
Such as this.
Which is basically
that's a miter.
Yep.
And we don't typically sleeve the inside of that. But where we do the sleeves is where you have the two tubes coming in. And
they butt together.
Yeah, then you got the joint inside.
Yeah, so that just keeps it with a solid piece on the inside there.
And it's a very tight fit inside. And
right.
We leave about an 1/8 inch gap. So that we do a root weld in between, so it penetrates all the way to the inner slug inside. And then if we're TIG welding, then we'll do another root pass on the outside.
Makes sense.
Or a final weld on the outside.
So using this chart, just because it's right in front of us here, all these tubes on the interior cage are, for lack of a better word, they're notched. That's basically what you guys call that, right?
Yeah.
Okay, so you have to use a special tool to do that. It's a tube notcher.
Yep, tube notcher, chop saws.
Yeah.
There's 3 or 4 different tools that go into play on that.
Yeah. So and then once they're notched,
good fit,
once they're notched to a good fit, you want to make sure they're nice and tight. That's when you can start to weld them together. Yeah. So putting those two pieces of tube together requires a welder, and what a welder does, in my basic understanding of it, is it melts metal together.
Yep. Pretty much.
Yeah. Some of my friends call it a glue gun.
Yeah.
So
that's all it's doing. You're just melting the two pieces together. Now in the TIG world, we can actually fuse parts together, not in off-road applications, but in other applications, you can actually fuse the metal together.
Interesting.
And weld that. So that's why in the TIG welder, we have what's called filler rod, and that's what's called filler.
Yeah.
You just basically you're filling over the weld. So you can do the root weld and just fuse it, or then you can use a filler rod to go over it.
Versus the weld coming out of the actual gun on a MIG welder. Right. Okay, makes sense. See, I've always seen TIG welders. They have like a foot pedal that they're using, and they have this rod in one hand and the gun in the other hand. It's just melting. Melting this rod with that torch, and it's just leaving a puddle.
Yeah.
And that's what's doing that together, just like that.
Exactly.
So, but there's a lot more to that too, which we can go into this for hours and hours. But when it comes to like proper penetration, and, you know, making sure that the integrity of the weld is good for the type of metal you're using. Make sure you have enough heat.
Yeah.
You know, too cold of a weld and you're not getting the penetration you need.
Yeah, exactly.
And then there's talk about porosity. Like I've heard all these terms thrown around. I'm sure that there's a lot that we can go into, but today we're just talking about the basics. So let's say I've got a bumper that I want to put a couple of tabs on, and I want to run a light bar on this bumper.
Yeah.
It's a tube bumper. Let's say it's similar to kind of like what you got over here. Yeah. So this is a tube bumper here, and let's pretend for the moment that these hella lights are not on there, and you got some tabs that you want to put on there. Maybe they're not even cut out yet. You just don't even know what shape they need to be.
Yeah.
So what would be the first step?
Well, first I'm going to have the light in my hand. I'm going to figure out where the lights are going to fit.
Yep.
You also want to make sure it's not going to be in the way of other things going on in the application. And then basically you're just going to kind of you're going to get a tape measure and just kind of measure out what size tab is going to work.
For the bottom of the light or whatever
the bottom
mount,
light,
the
and then figure out what size hole it is, so you can either, you know, you can drill the tab out.
Yeah.
And if you notice, these tabs have a little 45-degree bend.
Yeah, they're tapered a little bit, yeah.
And that gives it more strength, because in off-road racing applications, that tab eventually is going to start moving around.
Makes sense, especially when you have a big heavy light on it. Yeah.
Yeah.
So that's why they have these little bends in them. I've actually never really thought about that, but I thought it was more for aesthetics.
And if you hit a branch and stuff, it's likely chance of breaking the tab off. It's going to break the light first before the tab.
Right. That makes sense. Okay, so you figure out where you want to put those tabs.
Yeah.
And then let's say you have to make those tabs yourself. And for the sake of this argument, you don't have your badass CNC table over there. What would you do from there?
If you just want to do a rectangle tab, you can simply just measure it out with a tape measure, say 3 inches by 2 inches or 1.5 inches, whatever. And then you can just take those measurements in your head and go over to a piece of plate and trace it out with a Sharpie and just cut it out with a little cutoff wheel.
Okay.
But now, if you want more of a shape to it, you know, like a triangulated shape or something weird.
Kind of like how these are a little bit,
Yeah, then what we did is we get a piece of cardboard material. Chipboard is what it's called.
Yep.
And we basically cut it out with scissors, and whatever the application is going to best fit for this.
Yep.
Then we take that chipboard pattern and lay that on top of the plate with our Sharpie. Then we kind of mark that out, and then we either cut that out with cut-off wheels or with a handheld plasma cutter.
Yeah. Plasma cutters are fun, but they get a little messy too.
Yeah.
Yeah.
And not everyone can afford a plasma cutter.
Oh yeah. I've used one before. It was a ton of fun,
Yeah.
but man, did it make a big mess everywhere, and I had to grind everything off and make it nice and smooth.
So if you use a straight edge on a plasma cutter, such as a heavy block of steel, and use that as a guide for all your straight lines, then it actually comes out really nice.
Nice and clean?
Yeah.
That's good to know. I've never even seen someone do that before. Yeah.
So
Cool. So once you have it cut out, you're gonna, I'm assuming, bring it over to the bumper, and you're gonna do a little mock-up, right?
Yeah.
Kind of just see how it fits up against the tube.
And figure out where the drill hole is going to go.
For the light itself,
for the light, and make sure it's not going to hit the bottom of the tube or anything else.
Right. That's a good consideration.
And then, you know, I always put like a little crosshair, you know, with a Sharpie, and that's going to tell me right where to drill.
Okay.
And then we put it in the drill press and drill a hole, then basically we bolt it up, and we can use this as like a guide. Yeah. And then we can just simply hold the light in place, have someone else hold it if you want, and then you can tack the two pieces with a MIG welder.
So I know what tack welding is. Explain to our viewers what you just meant by tack welded together.
Well, basically a tack weld is just a small little weld, and what that does, that just temporarily holds it on.
Okay.
Now, because a lot of times we'll tack something on and it's in the wrong spot.
Right.
Or it's crooked. Because if you're sitting there holding it by yourself and you're like, well, okay, you stand back and you want to look at it and make sure it's straight, it's square, it's level.
Yep.
You want to make sure all three tabs are exactly even from each other.
Yep.
Now, if one is crooked, you can simply break it off. And if it doesn't break off, you can get a hammer, tap it off, or you can get a little crescent wrench and kind of wiggle it off, and it pops.
It'll kind of break that tack weld off of there, so you can readjust it and then tack it again where it needs to be.
Retack it again, get it at the right angle, and retack it again. And even at that point, you can TIG weld right over your tacks. But typically, we like to tack with the TIG welder for TIG welding applications, but
not mix and
depends what
MIG
it
and
is.
TIG.
You know, sometimes you can actually put a small little tack with a MIG if you do it right, and then you can TIG right over that tack. Got it.
So now you have the tab in the right spot. You have it tacked where you want it to be. You're going to take the light off of it so that you already know it's where it needs to go.
Yeah.
And then this is where the real work of, you know, melting metal comes in, where you're actually using, whether it's TIG or a MIG process welder, to actually, you know, attach the tab to the tube.
Yeah.
And this is where it's kind of hard to explain to somebody over a video how to weld something, but at least what you should have is some practice with things that aren't important, that don't have structural integrity to them, like a light bar or something.
Scrap metal, and start there and kind of just go from there. And all it is practice, practice, practice. Practice. It's like riding a bike.
Yeah.
You know?
And you see a lot of really beautiful welds online on Instagram. I see them all the time, and I see they call it like a stack of dimes, you know.
Stack of dimes.
And I'm assuming that anybody who's starting out with this stuff, certainly me included, is not going to have a weld that looks like that right off the bat. It's going to look kind of gummy. It's going to look like a little worm, you know. It may be blotched all over the place. Now, does the visual play a big factor in the structural integrity of the weld?
It does, and also listening to what the welder is doing.
Okay.
There's a certain sound, there's a crisp sound that you want to hear from the MIG welder. Okay. And it's a consistent sound, there's a consistent pattern. Like I tell my employees and stuff, just, you know, pretend like you're a machine or a robot, and you're every bead in between each stack of a dime is exactly the same sound. It's the same angle, it's the same consistency all the way through when you're doing it. So,
is there any way you can give us a demonstration of what a good sounding weld is and what a bad sounding weld is?
Yeah, absolutely.
Let's do that if we can.
Okay.
Cool.
Sounds good.
So Chris, as I'm seeing you here plugging in this Miller-Matic, there's always some question on like whether, if you don't have 220 power in your house or in your garage, will a 110 welder get the job done for certain things you want to do?
Certain things it will. Yeah. But typically you got to have the 110 plugged directly into the power source. Yeah. Anytime you put extension cord on it, you have an amp draw. Yeah. And it's just, you know, for anything like in an off-road situation, I would recommend a 220. Yeah. Just to ensure that you do get the proper penetration.
And that's got everything to do with how much power and heat is going through the gun, right? Yeah. So if you can if you only have 110 and you're going to make a few small tabs or something that's going to hold a bracket for like an antenna or something like that, you're probably going to be okay.
Yeah, you'll probably be okay.
Yeah.
There.
But if you're going to be building suspension components,
I'd recommend
definitely want to use a 220
power, just to make sure.
Yeah.
So,
and for a lot of people,
if you have a good power source on the 110, you might be able to get away with it. But, you know, it's
better safe than sorry. Yeah. A lot of people, if you don't know, if you don't think you have 220 at your house, your dryer probably runs on 220. So if you have a washer dryer, then so you can plug it right into that. You just won't be able to do your laundry at the same time. Yeah. So
might piss off the wife.
Maybe. Yeah. Cool. So we're gonna get this little demonstration set up for you guys right here.
Kind of rolled out here.
Yeah. So you want to ground it to something that's attached to whatever it is you're welding on. In this case, it's a table, so.
So kind of like,
for guys, just for safety, I'm not going to be looking at this while I'm filming it. I'm just going to be holding the camera close by, and I'm going to be turned the exact opposite direction. So, all right, so we're going to do a little tack weld demonstration for you guys here.
There's a tack. Let's put another tack on. Okay. Right there. And that's sounding pretty good right there.
Yeah. So that's held in place right now. Basically, you can let you mock up whatever it is you need to mock up.
Yep.
Okay. So that was the sound that you were talking about.
Yes. Yeah. Very crisp, clean sound. So now if it's popping and zapping and go
inconsistent,
very inconsistent sound, then you want to stop and kind of reassess what you're doing. So
is that a difference in what you're doing with your hand, or is it a setting on the welder that you have to change?
Okay. So there's a wire speed and then there's a voltage setting.
Yeah. So it could be, one of them could be off, or you can mess around with them to get the correct, kind of like tuning a guitar almost. Like you just got to mess with a few things until you can get the right sound.
So typically the heat is for the thickness of the metal. Yeah. And then the wire speed is also due to that. But the wire speed is what's going to dial in your welder. And so we're going to just do a little bit of a pattern. It's kind of like, imagine have a whole bunch of capital C's together. Okay. So, or like waves in the ocean. We're going to kind of, so that's one pattern. So
you're just going to go over.
Yep. And then you can swirl back. You know, you can kind of do that. You can go from the front to the back. And there's different applications for it now. Yeah. This is really easy to go straight, but now going around a tube is very difficult.
Right.
Yeah.
But for just a piece of angle iron like this, where let's say something was just someone's first ever fabrication project.
Yep, this is exactly what you're going to want to do.
Yeah,
something
like this.
Kind of stuff here. So I'm going to start here.
Okay.
You typically don't want to weld down
on an angle like that. Yeah.
So I'm going to get a. I use these blocks of steel to help me support.
Okay.
Metal. These blocks of steel come in very handy. You can get it at any metal supply store or scrap. This one was actually cut in a bandsaw, so it's perfectly square.
Nice.
So I can
give yourself a little easier angle to start on. Okay.
So I'm just going to start here and kind of weld down.
Okay. I'm going to try to angle my camera a little bit easier so I can see that.
Okay.
Okay.
All right.
That's good.
Yep, we're ready.
Go for it. Like that.
Yeah,
that sounded pretty beautiful to me.
Yeah,
very consistent sound, and then you got a nice, just a single bead going across that joint.
Yep. Your weld has to be as thick as the material you're welding to, or thicker.
Okay.
So this is actually thicker. I always like going, about another 25 to 35% thicker than what the actual material is.
So how do you gauge or determine the thickness of your weld? Do you just go slower as you go past it, or is it?
It's just more of a visual thing.
Okay.
I mean,
you just can see what you're doing when you're in there. Yeah.
Yeah.
That makes sense.
So just do a visual thing, and it's not so much the width of that; it's the depth of the weld.
I see. Yeah.
So there's a difference there.
Yeah. It's like how much it's going into that
depth of that weld
junction.
from there to there is actually a little bit thicker than the width of that.
Yeah.
So,
and that weld, although like on the outside to somebody like the untrained eye, looks like you just put a piece of metal basically in between those two.
Yeah.
It's actually inside the two pieces of metal.
Yeah, it's fused in there a little bit. So.
Yeah. And that's
now, if I turned it up really hot, then it would actually melt through the two pieces, and you'd see it
come out the other side.
On the other side.
Yeah.
But then you're overheating the molecular structure of the metal, and then which is going to weaken and fatigue the actual metal.
Yeah. And sometimes I've heard you can even warp parts that you're working with. If it's too hot.
Yeah, we warp parts all the time.
Absolutely. Yeah.
So
that's what you call the penetration of a weld, is how much it's penetrating into the two pieces that you're working with, or however many pieces you're working with.
Yeah.
And having that correct penetration is all dependent on the heat that you're applying to it and the actual placement of that weld, right?
Yeah. Exactly.
So more important for structural things like suspension or motor mounts or a cage or something like that, or safety items. But I think when it comes to just small, like at-home projects, it's not so much something that you have to worry about as long as the pieces are well stuck together, I guess, right?
Yeah, exactly.
Cool, man.
So
can you give me a demonstration of what a bad weld sounds like?
Yeah, absolutely. I'm going to weld inside of this now.
Got it.
Okay, ready?
Yep.
So you can tell it's a colder weld.
Yeah.
And it was a little bit less of a consistency pattern.
Yeah.
And see, it's a high ridge on the top right there because it's not molding itself into the metal.
Right. And it was a little poppy. It sounded almost like a wet fart.
Yeah. And I can make it work. So this is... So let's see here. Okay. So let's do this one now.
Oh, yeah. Wow.
So when you're hearing that, that's even worse. So
yeah. And it's just looking at it from here, you can see that it's huge.
You can tell the weld is hot.
It's sitting on top of the metal too.
Yeah, the weld is not penetrated into the metal where it's absorbing the heat.
Right.
So there's no heat absorbed into the metal. It is all stayed in the weld.
So you're essentially just throwing a blob of metal in between those two pieces, but you're not actually sticking them together.
Right.
Yeah.
There's no fusion in there whatsoever.
Right. And that's compared to the other side here.
Yeah. Yeah. This one was 100% fusion, which was good. Yeah. This one was a little bit less, but it still had some fusion to it. Right. So it'd still be a kind of a strong weld.
Yeah.
For certain applications, but I wouldn't trust my life on that with a suspension component.
No, or a safety component like a cage or something. Right. Yeah. So that was really helpful because I'm sure, to the untrained ear, you really couldn't tell the difference. Yeah. But I mean, just hearing them side by side was a huge difference. Yeah.
And sometimes even here in the shop, we're guilty of it too, where, we'll be welding on some, construction components where it's made out of 1/2 inch plate or 3/4 inch plate.
Very thick stuff, yeah.
And then all of a sudden, another employee grabs a welder and starts welding on some 1/8 inch and it's just too hot.
Yeah.
Or vice versa.
Yeah.
You know, so where it's making that sound, you're like, oh shoot. So you got to listen to what you're doing.
Yeah.
Because you don't want to do a whole weld where it's making that sound in that application, and all of a sudden you got to grind it off or
start all over.
Start over again.
Yeah. Yeah. That's a lot of time that you just wasted.
Yeah.
So
yeah.
very
Takes
cool.
a long time to grind those welds up.
Yeah. Oh, I can only imagine, man.
Yeah.
Probably longer than it took to weld it.
Yeah.
Yeah. Well, thanks for that demonstration, man. That was really cool to kind of see the differences in very basic way, you know, just a piece of angle iron on a piece of plate there.
Yeah.
Sweet.
And we didn't talk too much about the gas. Do you want to talk about that?
Yeah, so that's another component to every MIG welder anyway.
Yeah.
And that, and also give you my understanding of it, is it's a shielding gas.
Yeah, it's a shielding gas because oxygen is a contaminant when the weld is molten in that state.
So basically the end of that gun shoots out a little bit of that gas around the actual weld itself.
And there's a gas cloud that surrounds the whole weld in entirety.
And it keeps the oxygen from getting into the center of where the rod is coming through.
Yeah.
Yeah.
Yep.
And that's usually argon, right?
This is actually MIG weld. So MIG actually we use a 75-25.
Okay.
Where it's a mixed gas.
Okay.
So it's 75% nitrogen and 25% argon.
Okay. Both inert gases, obviously nothing combustible.
So yeah, 75% argon. It's carbon dioxide, 25% carbon dioxide.
Yeah, but it's basically there just to keep the ambient air around you away from the weld as it's going through. Yeah.
That's why typically you don't really want to MIG weld outside because it's going to blow that shielding gas away. Then
the wind will blow it away.
Yeah, if there's no gas in there, there's a bunch of porosity in there.
That's when oxygen gets into the middle of the weld that you're working with, and you get these little bubbles inside of it. And
if you want, let's want me to show you real quick.
Sure. Yeah, you just turn the gas off, right?
I'm going to turn the gas off.
Okay. Welds, because that leaves them to be very weak, and there's a bunch. It's like Swiss cheese on the inside of the weld.
It turns the weld into a sponge. It's very porous on the inside, so there's no strength due to that effect.
Okay, so let's demonstrate some porosity.
Okay. So let's go here.
Interestingly enough, it sounded fine. To me, it sounded like it was okay, but I'm sure you heard something different in there.
It sounds a little bit different to the trained ear,
but look at all those little pits and holes inside that weld. That's the porosity that we're talking about. That's just the air getting into it.
And if you cut that weld, it looks like that on the inside as well.
It's kind of like you said, a sponge. Yeah. I called it Swiss cheese, but kind of the same thing. Yeah.
Same thing,
Bad. Good. Also, don't touch any of this stuff for a while. It felt the heat coming off of it just now.
Yeah, it's hot.
Yeah. Chris, you were talking about tube notching earlier. Can you give me a quick demo on how you guys do tube notching? I mean, I'm sure there's different ways of doing it.
Yeah, there's multiple ways of doing it.
Yeah.
So a beginner way, because not everyone can afford a big expensive tube notcher.
Sure.
Belt grinders and stuff like that. But most people can afford a DeWalt chop saw from Home Depot.
Yeah,
so
absolutely.
$220 or whatever.
Yep.
So let's just get a piece of scrap tube here.
Wait, so you're using the chop saw to notch the tube?
Yep.
I gotta see this.
All right. So here's this piece of scrap tube. That's straight.
Yep.
So what I'm gonna do is I want to put this scrap tube here at this angle. Let's say we're gonna do a 45 right there. Okay. So let me grab my Sharpie real quick.
Every good fabricator has a Sharpie in his pocket at all times.
So in order to get this tube to sit down like that, we need to notch it from center down like that, and we're actually going to get it to sit in place like that. So I always put like whatever angle it needs, and then I also do a reference line. My reference line determines straight up and down.
Okay, got it.
Okay, make sure your safety glasses are on.
Yep, very important.
That's a very important thing for any kind of shop safety.
Yep.
Sometimes you can wear gloves, other times you don't have to on this. But so right here, I'm just going to go straight down. And there you have that look right there. Although we just did a straight cut, but since it's on round tube, it has an oval shape to it. So now watch what it does there.
Oh yeah, that fits pretty well.
See that?
Yeah. That's cool.
Now to clean that notch up, then we put it inside of our belt grinders or our you know, bench grinders and Burkings or whatever we got, you know.
And clean up all the burrs on the end of it.
Yeah, the burrs on the inside. Yeah, you want to clean that up. You don't really want to weld that.
Yeah.
So we were talking about porosity before. Believe it or not, see where the black right there?
Yeah.
That's all contaminated material. That's porosity from the chop saw, because it got red hot.
Right.
So the oxygen contaminated that. So you want to put that in a grinder and sand that material off.
With pure steel.
Yeah, because it's not going to be a big deal when you weld it, but you are going to introduce contaminated material into your weld, which isn't going to make it as strong. So it's going to be stronger to clean all that material off.
Yeah. So you want it to be nice and clean before you get any weld on there.
Yep.
Yeah.
So
that was pretty cool. Yeah, I actually never seen it done with the chop saw. I have friends that have like these weird, you know, like bench clamp with like a drill that has a hole saw on the end of it. That's what I usually see. Yeah, hole saw notchers. And
those work really well.
Yeah, they go through a lot of those hole saws, but yeah.
And for me, even when I'm chassis building, I still, because I have all those notchers too, I still go to here and then I go straight to the belt grinder, and the belt grinder just chews these things up. And
you find it's faster doing this, right?
Faster that way.
Yeah.
Probably should have my gloves on. So took care of the gap a little bit, and you can fine tune that if I keep going and
tightens it up a little bit. Yep, makes it less gap for you to have to weld.
Yep.
Yeah.
Anytime the metal's touching each other's, that's the best situation there.
Yeah. You want to have as much contact as possible.
Yep.
Yeah. I would love to know, as somebody who's just getting like their feet wet with fabrication, brand new, doesn't, you know, they have like all the hand tools and the wrenches and all that stuff, but they really don't have anything to start building a part out of raw materials. What are the must-haves for somebody who wants to get into fabrication?
So as far as the metal fabrication, the must-haves is obviously a welder. You have to have your welding helmet. I recommend a welding jacket, so if you're welding upside down, the splatter doesn't, you know, burn you and hit you. Nice pair of gloves, and also another pair of gloves, like work gloves for working with the metal.
Yeah, so you don't cut your hands up and stuff.
Sometimes the welding gloves are a little bit thicker.
Yeah.
You know, and those aren't really good for work gloves. You know.
Sure.
And some of the other must-haves, like what we talked about before,
chop saw.
Chop saw.
Yeah.
And the other thing are
these grinders, cordless grinders. Yeah. Yep. So you don't, I mean, necessarily, do you have to have one of those
out of
belt
those,
grinders?
I would recommend a bench grinder.
A bench grinder.
A stone bench grinder. Is pretty much a must-have, because you have to deburr all your material.
And you don't want to be doing that with one of these.
You can, and it depends on what it is. So if it's a big, long plate, then we're going to deburr it with a flap wheel disc.
Yeah, and you just go over it like this.
Run it back and forth on the plate. But now if it's a radius tab with a radius to it, we're going to put it in the stone, bench grinder, and kind of radius it out that way.
For sure.
Yeah.
Okay, so those are basically the basics.
Yeah, with those things right there, you can
start making cool stuff.
Start making a lot of stuff.
And a Sharpie. Don't forget a Sharpie.
Yep, Sharpie.
Yeah, got to have at least one.
And safety glasses.
Safety glasses if you're going to be doing anything with a power tool or cutting or anything like that. Yeah, for sure, want to be having those on. Are there any projects or anything you want to show us while we're here? Because I saw a cool little Can-Am outside. And
we just did a windshield for the customer on that Can-Am.
Yeah.
And we put some middle tires on it for the customer.
I saw those. Yeah, the Trail Grappler side-by-side tires. Yeah. Can we go take a look at the thing?
Yeah.
Cool. Let's go do that.
We actually built this windshield for him and the roof about 2 years ago. And he cracked the windshield, so he brought it back to us again to get the glass replaced in it.
So I personally haven't seen a lot of like glass windshields on side-by-sides.
Yeah.
It's something that I've seen before, but like it's not like a big thing. Is that something that's becoming bigger with these? Like more people are doing them?
Yeah. Especially for, we go to Glamis a lot.
Yeah.
And it keeps, when we're off-roading during the wintertime, it keeps the cold air from hitting you. So
not so much. You still have to wear a helmet when you're in this. Yeah.
Well, we go to Arizona a lot too.
Yeah.
Where there's no helmet law in Arizona.
Right.
So the wife likes it too, because it's not as cold of a hit,
with the air hitting you. Yeah. So you guys built this windshield, and this is everything around it as well. Is that what you're saying?
Yeah.
Okay, cool. And this is just some rubber seal that holds it in place?
Basically, I build the frames and then I send them out, and then there's a company, a local glass shop that
they cut the glass.
DOT glass.
Oh, okay.
So this is actual double layered DOT glass, which you want to use.
Yeah, it's tempered, so it's not
off-road.
Yeah.
Yeah, so that way when it shatters, it just crumbles.
Sure, sure.
So, and then they install it, so they give it back to me in the frame and ready to go.
And then you just basically, are these rivets, or there's, you have
these are threaded Allen button head stainless steel.
Oh, okay, yeah.
So we actually thread the tube inside.
Oh, nice, okay,
Yeah. It just threads right in.
Cool. And then you guys did the roof on this too.
Yeah, we did the roof,
Yeah.
We didn't do the cage or the other work, but just,
yeah. And then I saw a roof rack on the table earlier that you guys are building for the side-by-sides too.
Mm-hmm.
Yeah. That's super cool.
And then there's a couple 2-seat cages in there on the ground that we're working on. So
nice, man.
Yeah.
So yeah, there's a lot of customers out there for the side-by-sides out there, I'm sure.
Yeah, it's busy right now.
Yeah. I love this Land Cruiser behind you too, by the way.
Oh yeah.
Yeah. This is an 80 series, right?
Yeah, so we did the rear bumper and the swing outs and the side steps on this.
Yeah.
For a
beefy.
customer.
Yeah.
So the dual swing out.
Is that a footstep right there?
Yeah.
That's rad.
Yeah, a customer says he's gonna possibly put a roof rack on it in the future, so
that would tie things in nicely.
Yeah.
Oh yeah, dual swing out.
It's got rear integrated LED lights that hook into the reverse.
So when you pop it in reverse, those come on?
Yep. And if you're at a campsite, all you got to do is just put it in reverse.
Yeah.
With the engine off, and then it lights everything up.
And you guys engineered it with the tow hitch still there too, right?
Yep.
You have these big spindles here for the swing outs.
It's designed for a 37-inch tire.
For the weight of it bouncing around back there. That's one thing a lot of people don't think about when they build these bumpers. You know, they just, oh, okay, cool, I'll build a little A-frame. We'll throw a tire on it. It's like, yeah, that's not going to work.
It's got the big recovery hooks right there.
Yeah. So big shackle points there. Very functional, and like you were saying, walks that fine line between function and form. Yeah. Looks really good, man. Super cool. Well, Chris, I can't thank you enough for the tour of your shop today, giving us a few demonstrations. Yeah, thank you. And I'm sure that, my viewers are going to take away just as much as I took away from today's visit and learn a little bit about off-road fabrication if you're a complete beginner, just like this guy right here. So maybe one day I'll be able to start taking on my own small projects at home. What's funny enough is I have all the stuff that you just mentioned in my shop in the backyard. It belongs to a friend of mine.
Okay.
So I might just go back there one day and start dabbling and see what I can do. That's how it starts, right?
You got to start somewhere.
Exactly. Yeah. All right. Well, thanks so much, man. Appreciate it. Yeah. Take care. We'll see you.
Okay.
Yeah. Have it. Another great episode of Chasing Dust here at Welding Sparks, my friend Chris Begley's shop. Super awesome guy. I mean, I've known Chris for a few years now, and all the stuff that he puts out there is top-notch quality stuff. So I knew he would be the perfect person to ask about some of these welding and fabricating 101 tips that he gave us today. If you guys are interested in getting into this kind of thing and getting into fabricating, getting your hands a little bit dirty or your feet wet, however you want to call it, I think some of the tips that he gave us in today's episode are going to be very helpful for you if you're just getting started with this kind of stuff. And I know that I'm going to use some of the tips I learned today when I get started doing this in my own backyard too. And as always, I want to thank Nitto Tire and Driving Line for allowing me to have Chasing Dust on their YouTube channel. I really, really love making these videos for you guys. So if you guys enjoy them as much as I do, please go ahead and subscribe, comment, like, share these videos with your friends. They might find some stuff interesting in these videos too. And of course, if you're subscribing to Driving Line, we make all kinds of videos for all kinds of things automotive related, whether it's off-road, on-road, classics, street trucks, performance, tuners, all of that. We make some pretty great videos for that stuff, so check them out and see all the different great content that they're creating on this channel as well. But that's going to do it for today's episode of Chasing Dust, you guys. I'm your host, Matt McAdam, aka Desert Chief, only on Driving Line. I'll catch you guys on the next one.